like to introduce our third keynote, Dr. Khaled Hamdy. Dr. Khaled is strategic and project management consultant. He provided project management and business consulting services in Canada, Egypt, Oman, and UAE. His career spans over 30 years, and he is advisor to the chairman. His keynote title for today is Artificial Intelligence in Project Management. I'd like to invite Dr. Khaled Hamdy to stage, please. Please come to the stage and deliver the keynote. Thank you.
بسم الله الرحمن الرحيم. السلام عليكم جميعا. I first would like to start by thanking the conference organizers, Agile and me, Mirza for introducing me, and of course Dr. Muhammad Salama, the chair, for inviting me to speak at this prestigious event. I came here to speak today about artificial intelligence in project management. I discovered two things. The first thing is I'm overdressed for an Agile conference. Because most of the people who work on Agile are techies, computer experts. They don't believe in suits and ties, they believe in getting the work done. Well, maybe both, sometimes. So I will start by introducing myself. Who am I? I'm a civil engineer. I have a PhD in engineering. I'm a professional project manager. I hold a PMP credential. I work in RTA, Roads and Transport Authority in Dubai, and I'm a projects advisor to the Director General, or the Chairman of RTA. So, guys, what am I doing here? Speaking to a group of computer professionals, very high-tech people, about artificial intelligence. Why am I here? So, to cut the story short, you can go to lunch. No, really, the reason I want to speak about artificial intelligence in general and artificial intelligence in project management in particular is that it's a field that both interests me very much and fascinates me a lot. I think I can talk to you about the present, the past, about artificial intelligence a little bit, but I'll leave it up to you to develop the future of artificial intelligence and how it can help us. I'll speak about two or three main things. What is artificial intelligence? How is it applied or been applied in project management? And I'll talk a little bit about data mining and knowledge engineering. What is artificial intelligence? I asked myself this 3 years ago when I started doing my research and my reading in this field. Is it a science? Is artificial intelligence a science? Is it a technology? What do you think? Is it magic? It certainly looks that way somehow. These are screenshots from my Samsung Note 5, not 7, no, 5 phone. 1 week after I bought the phone, it started giving me those interesting messages. At 6:30 in the morning, it started saying, time to work, this much. And at quitting time, 13:50, I usually leave at 2:30, so about half an hour before. I work for the government, guys, so don't envy me. And don't tell the boss that I leave at 2:30 exactly. I try to impress upon him that I work too much. Anyway, the time to home. I didn't tell my phone where I lived or where I worked, what time I left to home, what time I left to work. It learned all that by itself. At the time, I didn't know exactly very much about how to set off and set on the GPS locator and things like that. So it collected all this information about me, and it learned from it. There is a process of learning here, right? What is it? The process of learning uses algorithms, right? That's science. Upon data that was collected from the phone. That's technology. To come up with this, which at the time for me seemed like magic. So I coined this phrase, and this is copyrighted, Khaled Hamdy, that artificial intelligence is a science that uses technology to create magic. Okay? I mean, it's lucky for me that I didn't use the Muslim license and marry 2 women. Otherwise, the phone would have had an issue, home 1 and home 2. But it actually recognized that for a friend of mine who works in 2 locations. Some days he goes to this location, some other day he goes to the other location. And the telephone started telling him time to work 1, so much, time to work 2, so much. So it is that intelligence, that approach. So what is the definition now, the official definition or a good definition of project management? It is the ability of a machine, whatever it is, a computer, a phone, whatever, to perceive the environment around it, to reason and learn from that environment, and to act upon it. This robot, if you look at it, it has sensors that can perceive the environment. It has some inference engine inside that can reason and learn. And finally, it has some effectors that are actuators that can act. It can move, it can give you a signal, or it can catch something or whatever, and these are actions that it does on the environment. Another definition of artificial intelligence is the ability of the computer to do tasks that are thought to require intelligence. And Snowden this morning spoke. He did a philosophy major and a physics major, and he will debate with me that intelligence is debatable. And it actually is. I am personally consider myself intelligent in doing mathematics, but I'm very stupid when it comes to playing football or playing music. So intelligence is not a universal thing. And so there is no human universal intelligence, so why do we expect to have machine universal intelligence? I mean, computers can do things that are thought to require intelligence, like deduction and inference, learning and adaptation, making decisions based on past experience, insufficient information, sometimes conflicting information, which is what we had as complex system this morning. That's when you have conflicting information. Can you make a decision? Can you move forward? So as there are many types of human intelligence, there are also many types of artificial intelligence. They can be categorized into 3 things: cognitive science, robotics, and the natural interface. And in the expert systems, learning systems, fuzzy logic, and genetic algorithms are all within the cognitive science. I will speak a little bit more about them later, but not into too much detail. I'll just touch the surface. Then, of course, in robotics, you know about visual perception, tactility, dexterity, locomotion, and so on. And last but not least is the natural interface, where you can see, vision, and so on. How long has artificial intelligence been around? According to my slide, it's been around for 60 years. Actually, 61 now. It started, and it was first created in 1956 in the UK, in Dartmouth College. They started speaking about artificial intelligence. The term was first created then. One of the very definitive texts on artificial intelligence that are still even being used today as a textbook for the course in the MIT Computer Science department was last published. I mean, I couldn't find a new edition of this book. It was last published in 1992. It's still taught in the computer science course of artificial intelligence, this very same book. The question that came to my mind then, and still comes to my mind now, is why is artificial intelligence so prominent now? Why do you think? Let me give you an example. Dr. Salama was talking to me this morning about self-driving cars, autonomous cars. Have you heard of them? How old are they? How old are self-driving cars? How long have they been around? 5 years? Less than 5 years. Would you be surprised if I said more than 30? This is an experiment that was done in Carnegie Mellon University. This paper was published in 1989, so the research was done even earlier than that. This is about Alvin, a self-driving van. This is Alvin. This huge van is Alvin. It uses more or less a lot of what the techniques are that are being used now in self-driving cars. Do you have any idea why it's so big? The computer. The back of this van, the whole back of this van is a computer that could do 100 million flops. The Apple Watch nowadays has 1 gigahertz, right? So this computer has 1/10 the computing power of the Apple Watch. And this vehicle could only go at 10 miles per hour because it couldn't process the driving data faster than this. And it was these images that you see, the one is a schematic, and the next one is the image that you could see on the screen within the car, yeah? Who has a Mercedes S500 here? I mean, definitely not me, but who has one? These are pictures. This picture on the right is from the S500. It has the same technology, the same capabilities that this car in 1989 had. It basically could follow a line, and it would stop if it found an obstacle in front of it. So this technology is so prominent now. It's coming. You see it. You see how much different the image is from 1989 to 2016. Why? Why is artificial intelligence becoming so prominent? First is technology, and second is the Apple Watch. No, the computing power that we have in our computers now. I mean, much stronger. You know, I mean, you're all computer techies, so you know Moore's law. Singularity is coming. So, in 1980, in the 80s, there were 3 Cray supercomputers in the world. I mean, when I was doing my PhD, I had to book time on a Cray supercomputer at the University of Toronto to do some runs. Right now, the iPhone 7 is more powerful than the 80s supercomputer. So 2 things have resulted or have come and have made artificial intelligence prominent. The advances in the computing power and, of course, the advances in technology. And that's a famous event in history when, in 1997, Deep Blue, a supercomputer from IBM, defeated the world champion in competition rules, chess. And I think it was last year that a Google program defeated the Go champion. Yeah? What was the difference? Why? Why did it take so long for... Why is Go more complicated? There are really no set rules. Sorry, there are set rules, but there are no set scenarios that you can follow. So the computer was doing, what it was doing is learning how things were evolving. This was sheer computing power. The computer simply computed all the possible moves that could be done, and he counteracted them. In Go, it was based on learning, and learning is one of the things that artificial intelligence claims to do. Again, about the computing power, how strong the iPhone 6 is compared to the Curiosity Mars rover that went to Mars. It's already changing our lives. Self-driving cars are coming. Robots are there. Medical diagnostics. and data mining and knowledge engineering. So what is the science behind the magic? Most of you know that. It's algorithms, computer programs that are written that try to mimic human intelligence, human thoughts, human behavior, some of them, not all of them. Philosophically, you cannot do all of them. Just there are so many tools and techniques. I touch on the simpler ones of them, not because you will not understand them, but because these are the ones that I could understand. So knowledge-based expert systems, artificial neural network, and genetic algorithms, and fuzzy logic. A knowledge-based expert system is simply a database. You put in all the information. The very first knowledge-based expert system were used in which field? Medicine, yes. To diagnose illnesses based on symptoms and to include all the medical knowledge. You include all the knowledge, you teach it through some if-then statements, and it comes up with answers to questions. So it provides what looks like expertise or looks like a good thing. Artificial neural network, it tries to mimic how our brain works. It's a set of neurons that do some computations on the data. The beauty of it is that it can find patterns in data that you didn't even think existed. And it can deal with numeric and non-numeric inputs, and at the output, it can also deal with numeric and non-numeric output. Just how the network looks. The problem with it, it becomes a black box. It starts playing with the weights between the different nodes, and it comes up with an answer. You don't know how the answer came about, so you are stuck. You have to rely on the network as it is. These are some of how the network works. I'm just showing you this. I'm not asking you to know what this is, but it's just that shows that it's all based on mathematics. It's a science. It's really a science. There is no magic in it. I mean, it creates magic, but it's not magic. Genetic algorithms are algorithms that rely on mimicking a human or biological evolution. They're called genetic or evolutionary algorithms. To do a big search, instead of searching everything, you start the process of selection or combining two solutions, which is marriage, in our case, crossover, and the other one is mutation. One part of you is working better than the other, so they take one part of this guy, another part of this guy, they merge them together, and they come up with a better solution. Fuzzy logic is how most of us think. We don't think of someone as simply tall or simply short. He's very tall, somewhat tall, whatever. And fuzzy logic tries to mimic that to solve some problems that are originally not solvable within the normal scheme of Boolean logic, which deals with things as 1 and 0 only. I would say that fuzzy logic really matches better the thinking behaviors of humans than anything else. Artificial intelligence has been used in project management. Have you heard of the use of artificial intelligence in project management? No. Why not? Because the field is not big enough to make it commercially viable for companies to invest too much money in developing applications that would help us as project managers use that. So, for example, these are some examples of the use of artificial intelligence in project management. Artificial neural networks were used to select the best structural system for a building. Genetic algorithms have been used to optimize the life cycle cost of building in hot climate. Knowledge-based expert systems are used to provide estimates. How many of you work in planning? Project planning. One of the most difficult things in planning is estimating. Yes? You estimated a range, right, in Ericsson. How do you estimate the range? Based on experts, expert knowledge. If you can have this expert knowledge programmed in a system that mimics human intelligence, then you can get maybe better estimates because you can combine the knowledge from many, many experts rather than the few that you have within your company. Databases can be done like that. Artificial neural networks have been used to automate the sequencing, to choose. A genetic algorithm, how many of us struggle with resource optimization and resource leveling? Actually, the programs Primavera and Microsoft Project use some sort of genetic algorithms to arrive at the optimum resource schedule or the optimum resource leveling of this. In cost estimation, it has the same effect and the same benefits as it does in planning. In risk management, we usually assign risks and you tell us high risk, yeah, maybe, medium, low. I mean, we do that based on usually rule of thumb. How we assign risks and how we assign the probability and the impact of risks, I think these are very, very important things, but you can do them very well with the use of algorithms and genetic algorithms. When you start a project, do you usually have any idea how late it will be? No. Do you have any idea how much over budget it will be? No. But sometimes you can guess that this project is very complex, so it will probably be longer than expected, right? But imagine you have all the information from all the projects done in your organization, thousands of projects done in your organization. And they are all programmed into something, an artificial neural network, so to speak, or an expert system that can find patterns, saying that if the project team, and it can find the pattern so that when you are starting a new project, you feed the information. Say, I have a project team of 5 people, 2 of them experienced, 3 of them are new. I have a subcontractor that is very experienced, but I have a very complex task and I have this and that. Then it can predict for you how much delay can happen or how much delay has happened in the past so that you can build your range in a better way than simply the opinion of the experts that you have in your system. I'm not saying it's the solution to everything, but it definitely will help. I worked on a research project myself to predict the behavior of taxi drivers in Dubai. I have a database of 8,000 taxi drivers. Age, nationality, religion, body mass ratio, all these things I could program in. These are my inputs. My outputs were how many accidents does he have per month? How many fines does he get per month? And how much revenue does he bring in per day? That is the information. So it could help us make a hiring decision. So, I mean, by the way, one thing, I'm Egyptian Canadian. So I was born and raised in Egypt, and then I lived in Canada. So when I did this research, I found that the biggest earners as taxi drivers were the Egyptians. But they were also the ones who made the most fines. Anyway, no, we use it only to predict the potential behavior of that taxi driver and to direct them to behavioral training. So if a guy is acceptable, he doesn't have any problems and so on, but you find that within his profile, he would be making a lot of traffic fines. So you start teaching him, training him, trying to modify his behavior a little bit so that he doesn't make as many fines as expected from the model. So I'm hoping to validate that model. It has been operational now for a year to compare the predicted results with the actual results. So in summary, artificial intelligence has been used in these different domains within the project management, but actually, the truth is like this. All the tools can be used in everything. Only I open up the eyes of researchers in this field that they can go and do this in different fields. So in summary of the first part, AI can and has been used in several applications in project management, enabling, hopefully, better project performance. I think it can make our life as project managers less miserable. I mean, I already concluded that our life as project manager is very miserable, but artificial intelligence maybe can make it less miserable, but maybe more in some cases. Because top management will come in and say, well, the AI application predicted that you will finish within this time. Why didn't you finish in this time? Yeah. I mean, this happens a lot. A little bit about data mining and knowledge engineering, because it's a very much related field and very interesting as well. The sources of data are machine, organizations data, and people data. Machine data, sensors, medical equipment, our mobile phones, our smart devices. They create a lot of data. According to sources, the engine of an aircraft creates about 1 terabyte of data per flight. Data about heat, about performance, about pressure, about all these factors, and they can use it to predict a lot of things, like they need to change a certain part or to formalize something or do a maintenance. The machine data is extensive, is tabular, is detailed, and it can be connected. I don't know if I have a picture here, but you know of the Internet of Things, yeah? Just a few weeks ago, my wife wanted to buy a slow cooker, what is called in the States a crock pot. So we were doing a search on the internet, and we discovered that there are slow cookers that can be Wi-Fi connected. So you connect it to your home Wi-Fi, and you're at work, you start it, you give it an order to start at a certain time, and it will give you feedback when it has finished. I mean, the connectivity is really great, and everything now is connected. I mean, it's the cars, everything, and this helps us a lot. Who was asking if it were legal? Somebody was asking if it's I mean, I don't know how legal it is, but when you connect to anything, they always give you this 500-line statement of privacy and whatever, and you agree to it, usually without reading it. And I'm sure they're collecting everything about you. Anyway, organizations' data. Organizations are banks, financial institutions, hospitals, departments, retail stores. All these, they come up with data that is good. It's tabular. But the problem is, it's variable. The bank has different data than the HR. Even within one certain organization, HR is different. The data in HR is different than the people in finance and then the people in projects and so on. So they are in silos. Combining them and finding useful information from them is very difficult. People data, the most interesting one. Facebook, Twitter, Instagram, YouTube. These from last year, these numbers, that every day the human population spends 20,000 years on Facebook. Every month we spend about 342,000 years watching videos on YouTube. So this data is huge. I mean, humongous, big. just to give you an idea how big the knowledge that is daily on Facebook, or the data that is daily on Facebook, is bigger than the knowledge that is stored in all the US academic libraries. And it's 30 petabyte versus 2 petabytes. Of course, you know what a petabyte is, but I had no idea before. So I made this table just to show you, for me to understand. I mean, my limit was a terabyte. I mean, and then it sounded too terrifying. So I stopped learning then, but then betabyte is 1,000 terabytes, and then there is an exabyte and zettabyte and yottabyte, and I don't know what. Anyway, really there is no limit, but the problem with people data is that it's unstructured. It's fragmented. It's variable, but it's very useful. I mean, of course you notice when you're browsing on Facebook or something, you get an ad about a hotel that you once looked at in booking.com 3 weeks ago, right? You bought something on Amazon, 2 weeks later, Twitter is sending you something about the same category of things. They use this, they analyze it. You write once on Facebook that you like football or soccer, and they come back and give you something from it. This is, when I was in university, I was doing engineering. They taught us that data, when you process it, it becomes information. That was the extent of my knowledge about this. Then they came up with all those different things, and the pyramid became bigger. I mean, coming from Egypt, of course, I like pyramids. So what happens? Data is the signals. They know nothing. When you give them context, they become information, which are useful and organized. You give them meaning, becomes knowledge, which is contextual and synthesized. And you give them insight, it becomes wisdom, which is understandable, integrated, and actionable. Again, my phone, it knew time and location. Because I didn't turn off the location thing, it knew where I was at any point in time. Then it had some information. It analyzed this information and knew that I spent the time between 10 p.m. and 6 a.m. in location A, and 7 a.m. to 2 p.m. in location B. So it deduced, that became knowledge. Location A is home, location B is my work. So it started giving me some wisdom, timely advice on the route to home and the route to work, as I showed you. Again, the same. With data, you understand the relations, it becomes information. You understand the patterns, it becomes knowledge. And if you can understand the principles somehow through machine learning or whatever it is, it becomes. Knowledge discovery has also been used, and data mining has been used in project management to better estimate the resources for certain types of projects. So remember two things. Artificial intelligence is a science that uses technology to create magic. Remember also that data is the currency of the future. People are using it for a lot of advantages for marketing and so on. I'll leave you with this, I hope. Seriously, any questions? Yes. Yeah. Yeah, go ahead.
Actually, I was really impressed by the amount of effort that in this session, but you know what? I'm afraid that this is in the same direction of dehumanizing the software entity, you know? Which is contrary to what Agile software development is trying to do, is to returning back the human factor in the industry. That we are trying to rehumanize things in software and letting the emphasis put more on people. Although I do believe that making sense of data is essential, and I really enjoyed the talk.
No, we are not talking about dehumanizing anything. I'm sorry, what's your name? We are talking about, guys, don't think of it as man versus machine. It's man and machine. The idea here is to enhance human capabilities, not to replace them. To use what is available to us as technology, as computing power, to improve the experience, whether it is the experience of working or the experience of living or any experience. There is no dehumanizing, it's only a matter of enhancing. Yes? To cognitive. Augmented or cognitive, yeah. Yeah. To emphasize that point, yeah. It's not man versus machine, and it's not machine to replace man. I have some interesting slides, I think, that come there. I will not show you the film. Thank you to the sponsors. I'm sorry, I should have had this in the beginning. Ask the computer. This question, self-driving car. What should it do? Go straight and kill 3 people, or go into the barrier and kill the passengers. Now I will complicate it for you. What if these 3 people on the street were children? What should happen? What if one of these people was a child of one of the passengers in the car? What should decisions be made? We have to be very, very careful about letting things control us. I agree with you, Amr. The artificial intelligence should not control us. You don't know who programmed the values here. Yeah, go ahead. You have a question or a point? I'm sorry, guys, I have diverging eyes. So I'm looking at Snowden here, but the guy in the end is thinking I'm looking at him. That's why I quit teaching, because it was very difficult when I wanted to point some student in the class. It was very difficult. I had to throw something at them. So please.
I think it's partly a point, and I think one of the reasons IBM have gone down that route is they've lost the AI battle to Google. I think it's a strategic repositioning because, I mean, if you can't write the program to replicate Jeopardy, you can't write the program, but Go was serious. Yeah? When Google replicated the Go player, that surprised a lot of us. But then you start to look into it, and you couldn't replicate the game. You could imitate the behavior of players.
Yeah, that's what.
I want to pick up something. I think the big mistake people make is to put the singularity up. Yeah? Because the singularity ain't going to happen. Yeah? If anybody really thinks that, their brain is probably ossified to the point where it may be possible for them. The basic fact is human brains do not process data, which is why a lot of us don't like the DIKW pyramid either. Yeah, the consciousness for humans is a distributed function of the brain, the body, and its connections. Yeah, and we don't make decisions in the same way as computers. So I think the point you're making now needs to be emphasized up front by not talking about Moore's law in the context of evolution of the human brain, because it's a very different process.
No, I'm just talking about Moore's law, that the computing power is advancing very quickly.
You just had the singularity top right on the slide.
Was it? I don't know.
You had singularity up there top right, right? It got allergic.
Okay. Yes, there was a question in the back. Sorry, Muhammad. There was a guy in the back. Yeah. Yeah, you.
I'm from IBM. We haven't lost the AI back.
Yes, Muhammad.
I just want to, I think the point about being human is very interesting, because just a couple of days ago I was attending a very interesting session run by KHDA, which is known as Human Resource Authorities, which is like our local education authorities here. And they were talking about singularity in education, and some very, very, very well outspoken people were talking about how the intelligence and artificial intelligence
about artificial intelligence as a tool, guys, not as our replacement. Yeah.
That's up to you.
Just to add to my colleague here, isn't there a danger that we become dependent?
We have already become dependent. There is no danger. We have. I mean, why don't you let go of your mobile phone? You're holding it in your hand. I mean, you're dependent on it.
My wife wants to know where I am.
Yeah. Taha. One more question, Dr. Taha. Yes.
Okay, I have an observation, combining Dave's interesting speech as well earlier and your interesting speech. Depending on the systems we have, and Dave explained these 4 different systems earlier, to select the suitable application to the system, because we have been, for example, developing artificial neural networks and fuzzy logic systems for cost estimation and planning for the construction industry for a very long time now.
Yeah.
But they have not been adopted.
Yeah.
All these big contractors and big consultants, they are not using it. And we have done so many conferences on this and explaining the whole thing. But when there is a simple, straightforward statistical analysis technique which can do the job for certain complex, for example, or linear relationship type of systems, then there won't be a need for complicated systems like fuzzy logic and artificial neural networks. Even if the performance is a little bit better or the same performance. So suitable and appropriate systems, appropriate tools will match certain systems. And that's why we wouldn't be able to convince these big organizations to adopt these artificial neural network systems or others for cost estimation or project management or planning.
I agree. They haven't picked up. The use of artificial intelligence has not been commercially used. But it's a fascinating subject anyway. Thank you very much.